Okay, so what we're going to talk about today is solving polynomial equations by factoring. In the Delta Math assignment with this, you're looking at real solutions only, or real intercepts, or real roots only. On this page, we're going to actually do some that involve some imaginary numbers. So you're going to have a couple of homework problems on this that are on this page in addition to the ones that you need to do in your Delta Math. Okay, so when we talk about solving polynomials by factoring, this is very much related to the solving equations or solving quadratics by factoring that we've done before. But it's been a moment or 5, so we're going to kind of talk through the steps again. First thing, anytime you solve anything by factoring, you need all the terms to be on one side and equal to 0 on the other side. It doesn't really matter which side of the equation the 0 is on, as long as you have the 0 on one side and everything else on the other side. Step 2, you got to factor the polynomial completely. So you're going to take part its factors as much as possible, and then you're going to set each factor equal to 0 and solve for the x values. Some of the solutions are going to end up being imaginary numbers. That's what we mean by complex solutions. Some of them are going to be square roots, and then some of them are going to be whole numbers or integers or fractions. But it just kind of depends on the polynomial to what you end up with. We're going to focus mostly on real solutions, but some things just don't factor down far enough and you end up with imaginary numbers. Okay, so solving by factoring, we're going to have to use all our different techniques of factoring. So you're going to use some that are GCF, some that are trinomial, some that are difference of squares, and so on. So problem 1 says x to the third plus x equals 0. So this one, the first thing I can do is factor out a GCF, and that's always should be your first step in factoring. So I brought out an x, and I have x squared plus 1 equals 0. And then I set each factor equal to 0. So I put x equals 0, and then I have x squared plus 1 equals 0. Over here, I'm going to subtract 1 from both sides, and I end up with x squared equals negative 1. Because I can't factor that any further, so I have to use square roots to solve it. I took the square root of both sides, and I get x equals plus or minus the square root of negative 1, which then reduces to x equals plus or minus I. And it's I because it's a square root of a negative, so it's an imaginary number. So I have one real solution, x equals 0, and then I have two imaginary solutions of plus or minus I. Okay, so let's look at problem 2. Problem 2 is not equal to 0, so I have to fix that. So I have to subtract 3x squared from both sides. So I have 4x to the third minus 10x squared equals 0. Okay, then always look for a GCF, and I have one. I can actually take 2x squared out of all of this, and I end up with 2x minus 5 in parentheses. And I got that by dividing everything by 2 and then taking x squared off. Then I set each factor equal to 0, so 2x squared equals 0. I divide by 2 and I get x squared equals 0, which means x has to be 0 to make that true, because the square root of 0 is 0. That doesn't get a plus or minus because it's 0. And then over here I have 2x minus 5 equals 0. So I add 5. I get 2x equals 5. Divide by 2. And I get x equals 5 over 2. Excuse me. Okay, so those are kind of the first two problems. Now, the second problem, and that one ended up only with 2 solutions because this 0 was actually repeated. The next problem says x to the third minus 64 equals 0. This one is already equal to 0, so I don't have to do anything there. So I can jump straight to factoring. This one, I have 2 perfect squares separated by a minus, so I can use difference of squares to factor it. So I get x squared minus 8 and x squared plus 8 equals 0. I cannot factor those any further, so what I did was I wrote x squared minus 8 equals 0. Okay, from there I get x squared equals 8. And then I take the square root. The square root of 8 reduces to 2 square root of 2, and then it gets a plus or minus in front of it. Because anytime you take the square root of both sides to solve, you have to put a plus or minus in front of the answer. Now on the other side, I have x squared plus 8 equals 0, so I ended up with x squared equals negative 8. Here I'm trying to take the square root of a negative number. The square root of 8 is still 2 square root of 2 reduced, but it gets an I because it's imaginary. So this is my 2 real solutions, and then I have 2 imaginary. These are what I call real roots or x-intercepts. These are what we call imaginary roots. So these where it actually crosses the x-axis on a graph. These do not. Okay, we're going to skip problem 4. That's one you're going to do on your own. So you're going to work through problem 4. And I'm actually going to go to the next page and look at a few problems there. Okay, so problem 5 is perfect cubes, and I've got the example written out, but I actually want to do problem 6 with you guys, just to kind of show you how that looks and when you need to use the quadratic formula. So let me zoom in a little bit. Okay, so on this problem, the reason why I wanted to look at this one is if I look at it, first of all, it's not equal to 0, so I had to fix that first. So I'm going to go ahead and I'm going to subtract 4x squared from both sides. So I have 8x to the 5th plus x squared equals 0. So I have 5 and I subtracted 4. Okay? And then I'm going to factor out my greatest common factor because they have an x squared in common. So I'm going to have 8x to the 3rd plus 1 equals 0. Now this happens to be a sum of cubes because 8 and 1 and x to the 3rd are all perfect cubes. So I'm going to have my x squared here, and then I'm going to put 2x plus 1. And I has 2x because this cube root of 8 is 2, and then x to the 3rd becomes x. And then here I'm going to have 4x squared minus 2x plus 1. And I use the sum of cubes formula, or the sum of cubes rule, to solve that. Okay, then I'm going to set each factor equal to 0. So I have x squared equals 0, and I can solve that, and I get x equals 0. So that's my first real solution. I have 2x plus 1 equals 0, so I solve that for x. And I get x equals negative 1/2. That's my second real solution. And then this does not factor any further, and it's a quadratic, and there's like no good way to solve this. So this one I actually have to use the quadratic formula on. So I'm going to write x equals negative b, so that becomes negative 2, so it's plus 2, plus or minus the square root of negative 2 squared minus 4 times 1 times 4. That's 4 times a times c, all over 2 times 4. So I'm going to have x equals 2 plus or minus, if I work all this out, it's 4 minus 16, so it's negative 12 over 8, which means this one's going to be imaginary. And I'm going to come up here to work it up the rest of the way. So I'm going to x equals 2 plus or minus 2 square root of 3i over 8. And then because all my coefficients are divisible by 2, so 2, 2, and 8, I can divide them all by 2. My final answer is going to be x equals plus or minus 1, or sorry, x equals 1 plus or minus the square root of 3i over 4. On Delta Math, you're asked for the real solutions only. So since you know, like when you come down here, it's square root of negative 12 and it comes out imaginary, you wouldn't have to continue working on it. But if they asked for an imaginary solution, then it would be that. Okay, let's look at a couple more problems on here. And sum of cubes always comes out that way. So it always comes out, or difference of cubes as well. Anytime you have sum or difference of cubes, you're always going to have something that's real and then other parts that are imaginary. And the real part is the first set of parentheses and the imaginary part is the second set of parentheses. Okay, so let's look at number 8. This is another one that this is going to be a difference of cubes. So here we're going to subtract 54. And you're going to get 16x to the 3rd minus 54 equals 0. Because remember, you have to set it equal to 0 first. Okay, and then 16 and 54 have a common factor of 2. So you're going to divide them by 2. And you're going to get 8x to the 3rd minus 27 equals 0. And then we're going to factor this. So 8 becomes 2 because that's the cube root of 8. And then 27 becomes 3. And then in the second parentheses, you're going to have 4x squared, because you take the first term and square it. And then this time it's a plus. You multiply the two together to get 6x, and then plus 9. Okay? Now, setting each factor to equal to 0, if I set 2 equals 0, that can't ever happen, so I'm just going to cross that out. X minus 3 equals 0. Add 3 to both sides. I get x, 2x equals 3. Divide by 2. I get x equals 3 over 2. Okay, and then for the last one, 4x squared plus 6x plus 9 equals 0. I'm going to have to use the quadratic formula again. So it's negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I get x, and that's 2 times 4. I get x equals negative 6 plus or minus the square root of 36 minus 16 times 9, which is 144. So I get x equals negative 6 plus or minus the square root of negative 108 over 2 times 4, which is 8. And I'm going to come up here to finish it. Negative 108 is not a perfect square, and it's also imaginary. So I'm going to simplify that, and I get negative 6 plus or minus. The square root of 108 simplifies into 6 square root of 3, and then I, all divided by 8. And then because I have all even numbers, I can reduce it even further, and I get negative 3 plus or minus 3 square root of 3i over 4. Okay, that one's kind of a tricky one. You have one real solution, and that's 3 over 2, and then 2 imaginary solutions right here. Okay, let's do one more example with a trinomial. So I want to look at the third page with trinomial factoring. So I want to do number 11 and 12 on that page. So number 11 says x to the third minus 8x squared plus 16x equals 0. So we're going to factor it. We're going to start by factoring out the GCF, which happens to be x. So we're going to say x parentheses x squared minus 8x plus 16 equals 0. And then we've got to break this down even further. So we're looking for what can we multiply to get 16 that adds up to negative 8. And that happens to be negative 4 and negative 4. Okay, then we set each factor equal to 0. So x equals 0. X minus 4 equals 0. So x equals 4. And then x minus 4 equals 0. X equals 4. These two solutions are repeated, so they have what we call multiplicity. But these are your answers, so you would type in 0 and 4 as your real roots. Okay? Number 12, you're going to work on your own. So that's 2 problems off this page or off this section. You need to work on your own, number 4 and number 12. All right, so to wrap this up, we're actually going to skip 13 and 14 because they come out kind of strange with weird fractions, which is kind of beyond the scope of what we want to do in this section. So we're actually going to come down and look at 15 and 16, which involve factor by grouping. So 15 and 16 involve factoring by grouping. 15 we're going to work through together, and 16 you're going to work on your own. So there's one more problem to do, which will give you a total of 3, which is not terrible. But if you need help with it, let me know. Okay, number 15, let's look at how we can factor that. So factoring by grouping, anytime you have 4 terms, you have to use grouping. You should always look for a GCF first, which this doesn't have one. So then I'm going to look for what happens with these 2 groups. So x to the third and 2x squared, they do have something in common, and it's x squared. So I'm going to take x squared out, and I'm going to have x plus 2. And then 5x plus 10, I can take a 5 out and get x plus 2. Okay? And then remember, you take your matching parenthesis and you write it down once. And then you write the other stuff in the second parenthesis. So we have x plus 2 and then x squared plus 5 equals 0. We've got this fully factored. I can't break it down anymore. So I'm going to say x plus 2 equals 0. Subtract 2. And I get x equals negative 2. Okay? So that's my first solution because I just took that parentheses and set it equal to 0. For the second one, I'm going to say x squared plus 5 equals 0. I'm going to subtract 5. I get x squared equals negative 5. I've got to take the square roots this time. I get x equals plus or minus the square root of 5, I. And it's imaginary because I have a negative underneath the radical. So I have one real solution at negative 2. That's an x-intercept where it crosses. And then I have two imaginary solutions at plus or minus 5, square root of 5, I. Okay, so 16, try to work through on your own. A number 16, you're actually going to have 3 real solutions, just so you know. And then delta math, you have 6 problems to do. Make sure you watch the video I made on how to type in the answers on delta math because it's a little bit tricky. And know that on the delta math, you're looking for x-intercept, so they want the real solutions only. So in delta math, if it looks like it's going to come out imaginary, you can ignore that, okay? All right, so we will talk about this some more on Monday a little bit, and then we'll start getting into division next week.